right, here we go. Do a little bit more 6.5 for you today. Okay. We're going to look at example 652, which is going to be all about modeling with polynomial equations. Okay. So hopefully, if you're lost, you today and during notes, you're using this to study for our quiz tomorrow, which you're going to have on 6.5. So here we're going to start going over word problems. All right, we're getting closer and closer to the real world. All right, so for example 652, we have the product of two consecutive odd integers is 323. Find the integers. Okay. So I'm going to start by pausing my video and making a number line for you. I'm going to make a number line. Okay, so I went ahead and made this number line, and it's not a regular number line, okay? So I went ahead and made all my even numbers above the number line and all my odd numbers below the number line, okay? You'll notice zero's in a box in the middle because zero, it's not above or below because it has no sign. Zero has no sign. It's neither positive nor negative. Okay, all positive or negative means is what side of zero a number's on. Okay, so zero is on neither side, so it's not positive or negative. Okay. All right, so first thing I want you to think about is where my odd integers, they're below. All right, what are consecutive odd integers? Well, 1 and 3, those are two consecutive odd integers. 5 and 7, okay, -5 and -3. -1 and 1, all consecutive odd integers. Well, how do we get from 1 to the next? Okay, so if I start at 1 and I want to get to 3, what did I do to get from 1 to 3? I added 2. Okay, how about from -7 to -5? I added 2. Okay, so we see a pattern here, right? So for consecutive odd integers, all you do is add 2 to get to the next number, the next integer. Okay, so let's let n be our first odd integer. And then so if we just add 2 to get to our next integer, if our first one is n, can't we just say n plus 2 is equal to our next odd integer? We're allowed to do that, right? N plus 2, next odd integer. N, first odd integer. All right. Now we need to stop and think about the problem. We are finding the product of these two consecutive odd integers. So there they are, n and n plus 2. So if we're dealing with products, don't we just multiply these? So let's multiply them. N times n plus 2. And what do they need to equal? 323. Okay, now we solve. So distribute our n. We get n squared plus 2n is equal to 323. I'm going to subtract that 323. Okay, and now here's where a bit of math's involved, and I'm going to show you the quickest possible way to solve this, okay? So, because we need two numbers that multiply to be negative 323, but add to be 2, okay? So I don't even know what numbers go into 323. So I'm going to have to start dividing here, okay? So let's just go down the list. So we'll go over here. So you might start with, okay, we're not going to do 323 divided by 2 because this is an odd number, but we could do 323 divided by 3. So 323 divided by 3 is actually 107.7. That's not it. What about 323 divided by 4? Well, we don't actually have to do this because this is an odd number. Okay, and 4 isn't prime. 4 isn't prime, so we're only dividing by primes. So how about 323 divided by 5? Now, you might have looked at this and said, no, 5 doesn't fit in there. I know that. That's obvious. But we did it anyways. So that would actually equal 64.6. So it's not that. All right, we're looking for an even answer when we do this, right? So 323 divided by 7 is 460.1, 46.1. Okay, so that's not it. 323 divided by, would I do 8? No, because it's even. Okay. Would I do 9? No, you don't do 9 because we already did 3. If 3 doesn't go in, 9 sure as heck ain't going to go into 323 because 9 is just 3 times 3, isn't it? So 323 divided by 11 is actually the next number we check, and that is 29.4. We're going to do 12? No. 323 divided by 13 is going to be 24.8. We don't do 14 because that's even. We don't do 15 because that's not prime. We don't do 16 because that's even. 323 divided by 17, though, gives us 19. We have our lucky winner. Okay. So, since we need 2n left over, I know my bigger number is going to be positive for my factoring. Okay, because if you add these together, you get 2. If you multiply them, you get negative 323. So now, n plus 19 equals 0. N minus 17 is equal to 0. We solve. N is equal to negative 19. N is equal to positive 17. Are we done? No. These are not consecutive integers. And let's go back to what we set up here. Okay, so they need to be 2 consecutive odd integers, all right, that multiply to be 323. If we multiply these, we don't even get positive 323. We get negative 323. What we have are 2 n's. So with every n, we have an n plus 2, don't we? So here, our n plus 2, wouldn't that be negative 17? And here, our n plus 2 is 19. And if we check, negative 19 times negative 17 is positive 323. That one's good. And then, of course, positive 17 times positive 19 is positive 323. They are consecutive integer pairs, so our answer would be negative 19, negative 17, and 17, 19.